this lecture so we don't lose more people. Um, Welcome back to our fun class. We are going to talk about pointers and memory allocation today. And the parenthesis is, I think, meant what it means. This is where the fun really begins. Um, Interpret that smiley face any way you want to. All right, but before we go there, let's start with an array. Everyone knows what's an array, right? Can someone tell me what is an array? Does Python have an array? Awesome. Especially, I remember you take funpar as well, right? So if you take funpar, Python has a list, which is a list is different from an array, actually. Uh, if you're taking funpar, you will realize that a list has infinite. It can have any number of items on the list, but an array has a fixed number of items, right? Array is kind of unique in a sense that you need to know the size or an array. By definition, right, it's a collection of data that has the same type, right? What is a type? Anyone remember what is a type? What is a data type? Like float, integer, right? Character. How do you in that case, if we have an array of character, what does that becomes? What is an array of character? Is a string, right? So in C, we don't have the actual data type called string, but it's going to be literally called array of character. So that's how C represents a string. In C++, there is a string. In C, there's no string. You just use the actual like array of character, right? Array is also contiguous in the memory. This is basically where the elements of system programming, element of C comes into play, right? What is a memory? When you buy a memory, how can I visualize the memory? How does everyone here, like everyone of you guys, how do you visualize the memory that you buy? Okay, let me kind of go back one step. What do we use the memory for? To store data, right? To store something that you want to store. And let's say you have a storage somewhere. What do you need to be able to organize every single data that the computer is using, right? So memory, the way you visualize the memory is simple. Think about it this way. It's like basically it's a long flat area, right? Has a starting place and has somewhere that it ends. That in the middle you can store the data over there. How can I tell where is my data? What can I use? What is a okay? Let's think about real life, right? How can I tell the location of myself? I can use the address, yes, right? The address tells me where is my data. So if I say array is contiguous in memory, what does contiguous mean? So if I have an array, right, that has 3 elements, which basically becomes A0, A1, A2. So in C language, right, A followed by a bracket, the bracket specifies this is an array. So A3 means it can mean two things. When you declare, it means it's an array with the size of 3 items. If it's paired up, it's not being declared, it's being used, means that it's the fourth element because we start from 0. So A0, A1, A2, A3. A3 is the fourth element of our array. It's contiguous, which means that our array called A is here. Everything is connected to each other. It's next to each other. A0 would be here. A1 is here. And then A2 is here. Any questions so far? Any questions so far? Because we're going to play with this notion a little bit when you go with pointers. All right. So let's assume this is it's not our assumption, actually. This is actually what happened. When you have an array, it's next to each other in memory. In C, you use this bracket this type of bracket to specify the array of certain data types, like int I10 means that it's an integer array called I that span from I0, I1, I2 to I10. Is it possible, question from the chat, is it possible that there's not enough space for an array of specific length? Yes. Array of, okay, let me ask you this question. What if I want to allocate an array of size like, I don't know, 5 trillion integer? What would C do? There are two options, right? The most common option, C would say, I cannot allocate the free space for that array. And the function that would perform the allocation or the compile time, depending on how you initialize the array. If you use pointers, it would yell at you saying, hey, I don't have enough space for that. If you use this format, but in the number instead of 10, you put in like 1 trillion, it will basically, when you compile, it would basically say there's not enough. Like there'll be an error say we can't do that because not enough the space for your array, right? So what can you do? What can you do? You can use pointers to kind of like work with a portion of your array at a time. It's actually never really I guess unless it's some specific instance, like you don't need to actively use that much data at the same time for most programs. Modern day programs, probably not. Now you can probably use a lot of data as well, but you might want to basically strategize over how are you going to access them, right? What else? What else beyond array? So hopefully that answers your question. What if there's not enough space for an array? Does it? Or anything unclear or anything that you have? Like any questions you still have? There's also a config where you can say how much space are you willing to give to each program as well. Because at the end of the day, you like the memory is a physical thing. It has a limitation that say that's the size, right? So you sometimes you can't go beyond that. All right, what else? So what if I want to create something that's more flexible, right? You can use a data struct for that. So let's say I want to create a data type for the date of birth, right? So what should be stored in your date of birth? Day, month, and year, right? So basically those are 3 integer, right? I guess you can do 2 character, right? Because character is 0 to 255, so you can do 2 character and 1 integer as well. But I mean, let's just simplify that. We will store a date of birth with 3 integer, right? I guess you can use an array for that. But what if we use data struct, right? Data struct is a way to combine multiple elements into one single unit, right? And the way you define, by the way, is actually lowercase s, not uppercase. I'm sorry, the PowerPoint just like I'll do the autocorrect for me. So you can call the data type called struct followed by name that you want. This is your name that you want. Basically, whatever name you want to name the struct. In there, can someone guess what's in there? In this bracket. It's basically whatever data you want to store. Yes, the variable that we need and you want to combine together into the struct, right? That's why it's called a struct. It's gonna create a structure called some name in this case with an integer and a float. And you can refer to this struct some name again by using the dot. Dot would give you the access to each element, right? Dot A would give you the integer one. Dot B would give you the floating point one. And then you can combine the concepts of array of structs as well, right? You can do something like this: struct some name and then followed by the actual data. This is a variable name. This is the data type, like struct name. So it's a struct some name, and the actual variable is called ARR name, and we have 1,000 of those. Then you can access the integer elements of the first one by doing ARR name 0.a, right? You can also define a new data type using the keyword typedef. Typedef stands for type define. It defines another different name, because otherwise, whenever you want to create this struct, you always have to do this struct, right? Sorry, PowerPoint is fighting with me again all the time. I want to delete this. I can't even erase that for some reason. You will have to do this struct some name a, right? That basically would create the data type struct some name called a. And if you want to create another one, you need to type in this struct some name b, which is annoying, right? One thing I can do is use the type def. Once I do this type def, I can just say new name c. It would do exactly the same thing as the earlier statement where I create the struct some name. Any questions so far before we move on to pointers? Now we talk about most of the data type that we need to talk about. We talk about the way to define a new data type. Now we are going to talk about pointers, because that's also an entry into how to deal with like input file, output file, and dealing with the part of the assignment 2, where we have to deal with input and output file. And we're not going to actually directly work with pointers yet. Pointer will be assignment 3. Any questions so far before I move on to pointer and before I start the fun of this class? All right, so let me ask you this question, right? How does C store the data? So I said to you that every single piece of data and variable and program actually is used to store somewhere in the main memory, right? So to know where they are, each data, including the program actually, is associated with an address. Think of it as a home for the data, right? So in C, every single variable has its own address. The array also has its own range of address, and hopefully you access things within the range. Can someone tell me if I I try to access an array, but I went outside of the range, what would happen? It's gonna throw an error and say it's out of range, right? Specifically in C, when you run it, it's like you say segfault. You're gonna live with this word for a long time. Segfault, segfault. It actually stands for segmentation fault. There's a historical reason why it's called segmentation fault, and we can touch on this topic when we talk about virtual memory later on in the third module. But we will kind of look at this for now, assuming that compare this in a real life scenario, right? Compare this to the real life scenario. It's like if I want to go to my home, I go to an address, but then there's some typo in an address. I walk into someone else's home. What would happen? Because yeah, you're gonna get arrested. Someone will call the police, right? And I'll get arrested for trespassing into someone's home. Exactly the same thing as in the computer world, right? Someone tried to access a piece of data that you do not own. You're trying to access a piece of data that you didn't own. The OS, think of the OS as the police, right? Linux, Windows would basically say, hey, that's illegal. I will actually kill the process. Okay. In real life, police are likely not to kill me, right? But in the computer world, right? the one thing that's likely to happen, OS detects that something wrong is going on here. This program A is trying to access someone else's data, so it's gonna be like, I'm gonna stop the program from running by killing that program. Yes, that comment is actually can be true. If you are in the United States and you walk to some random people's home, that can be really dangerous too. Don't do that, guys. Also in C language, you can also create a data type that store the addresses, right? Technically, the array that we created also has the same data type. This is called a pointer. What does pointer mean? Can someone tell me the meaning in English of the word pointer? That actually is a really, really stupid question, but I want to stress the point that everything we talk about here is really simple. Yes, it point to something. It's a thing that point to something. It's like indicator. Yes, everything is correct here. Something that point to another thing, right? That's what we use the pointer for. It stores the address, right? So let's visualize the memory address, right? Over here, we have, let's say I have an array, right? And inside the array, I have the data 0, 2, 3, 7, right? I have the data 0, 2, 3, 7. And let's say all of them are integer. And can someone give me the size of an integer? Give me a size of an integer. By the way, depending on how you define it, it can be different sizes. But let's go with the default C integer size. This is 4 byte, right? Now, can someone throw me a random address just for the starting point of this array? An address that tells the starting address of this array. Can someone tell me that random number? This is your memory. And memory start from byte 0. This is also address 0. To basically whatever byte is the size of your DRAM, right? So can someone tell me the address? Can someone give me an address between 0 and infinity? 1. Yeah. Maybe a little bit high. 1 works. 1 works. Let's go with address 1, right? Address 1 is byte 1. Also address 1. So let's say that's the beginning of our array, right? If I look at this byte, what am I gonna see? The number 0, right? What's next to the number 0? What's next to the number 0? The number 2. And then followed by the number 3, and that's followed by the number 7, right? And how big is each of this number? How many bytes is each number here? 4 bytes, right? But that's kind of like our assumption that I said earlier. Integer, let's assume that's 4 bytes. So this block is 4 bytes. This is also 4 bytes. This is also 4 bytes, and this also is 4 bytes, right? So if I say the word 0, sometimes we call this data word, start at byte 1, where is the starting point of address for the number 2? Byte number 5, right? This is byte 5. This is byte 9, and this is byte 13. All right, everyone with me so far. That's basically how I put the array in my DRAM. Let's assume there's no virtual memory or whatever. Right now, let's assume this single flat address. I have an array, and that's how I plug in this number. Right? Hopefully this is clear. And that's basically data versus address. If I have int a equals 10, a is a variable that stores the value 10. If I want the address of A, anyone write C code before? How can I get the address of A? Ampersand A. If you deal with scanf, if you deal with the function scanf, do you see something familiar? Ampersand and that variable name will get you the address of where this value 10 is. So again, technically, just because I want to make sure these things are correct, technically this is a virtual address. It's not the actual location where we store this in DRAM because we have a system called virtual memory that would deal with many things that we're gonna cover in module, the last module. I think we changed, actually module number 4, yeah. That's like toward the end of this semester, but we learned that too. Data versus address example, right? Again, let's go with that array. 0, 2, 3, 7, that's the data, right? The location, byte 1, byte 5, byte 9, and byte 13 is the address. So clear? Clear so far? Clear so far? If we are clear so far, high level abstraction concept behind pointer is that pointer store the address. That's it. Pointer store or RE the address. That's all. All right, we're done with this class. Joking. The thing is, conceptually, this seems simple. But you're gonna have a lot of fun in this class when you try to use pointers because there are so many ways you can program fun that things can go wrong. But always, please, when you are confused, go back to this diagram. That's a data and that's a pointer. And draw things out on a piece of paper, a whiteboard, somewhere. It helps, really helps try to visualize where things are in your code, in your program. You can have a pointer to another pointer, yes. That we will cover that next lecture. Right? For now, let's go with just a single level pointer. That's where the real fun begins. Now it's just a fun. Next lecture is real fun. So in star A equals 10 is what? Now in this case, A is a variable. But what does A store? Because the way we declare pointer, right? We declare pointer this way. A is a pointer. So A now is a pointer that store the address. The address would point to the location that has a data value 10. In this case, right? You have some value 10 somewhere. This is the address. And this address is going to equal to value A. A is the value that represents the address. The address point to the number 10. The number 10 is in the memory. All right. Star A, star is the operation. So in this case, star is the operation. If you put star in front of a number, a variable, right, is called dereferencing. So you have a reference, you dereference from pointer to get the value. You can also do the ampersand. Ampersand is called referencing. So ampersand a value, you get the address. Ampersand a variable, you get its address. You star a pointer, you get the value. It's just going back and forth between pointer and the address and the value, right? You can also make pointer point to other variable as well, so you can reassign what you want to point, right? You can also do operation on a pointer. A++ will go to the next elements of A. Fun fact. Let's say A is an integer pointer, right? And let's assume from our example, we have the number 0, 2, 3, 7, and this byte 1. And let's say this is A. If I do A plus plus, what is my address? Do I get byte 2 or do I get byte number 5? The keyword is go to the next elements of A. A is an integer pointer. If I do plus plus, it will go to byte number 5 because the next element is not on byte number 2, it's on byte number 5. When you do a plus plus on a pointer, you need to check the data type of that name. In this case, the data type is an integer. Integer is 4 bytes, so you go 4 bytes at a time. If A is a character pointer, then you go 1 byte at a time, right? What about an array? Array is technically is a pointer that covers a certain range, right? So it is, if you can have, let's say you have an array of integer like 0, 2, 3, 7, the same example, right? A pointer can also move up and down that range. So when you write in A5 to get the 6 elements of A, again, array start from 0, A5 is the 6 elements. This is the same as you do A plus 5, right? You go to the 6 elements and then you dereference. Assume that you have the memory allocated already for A. All right. You can also do ampersand A5. Sorry. I wonder if I have a pointer type int that we reassign the address to a char. How does the pointer respond? So is this something like this? Let's say you have int star A, right? And then later on you say char star, you cast A into a character pointer. Is that your question? Like, let's say I do this. Okay, so let's say I do this. I have int star A, and let's say A point at byte 1, the same example, but now I cast A into a character pointer, and I do plus plus on that character pointer. Do I get byte number 2, or do I get byte number 5? Now that I cast A into a character pointer. It actually will go to byte number 2, because now this version of this statement, like that line, we are now referencing the character pointer, and you increment the character pointer. Character is 1 byte, so you move from byte 1 to byte 2 instead of byte number 5. Is it clear? Sorry, it might sound confusing. Okay. Now, is your question something like this? I have the value 0, 2, 3, 7, right? And this is A. Now I have something like this, char star B equals A, and then I do B plus plus. And I want to dereference that. Is that your question? What would happen if I do this? Ah, awesome. So this is a great question because it's actually quite tricky. What is the type of B? What is the type of B? Actually, let's start from the beginning. What's the type of A? So to answer to Robert, sorry, while in the meantime, right? It's an integer. Yes, A is an integer pointer. Actually, integer pointer. It go up by the amount of bytes that the data types take. Yes, yes. So if I ask this on your exam, you should now be able to answer this. So if I do char star B equals A, right? What would happen is it takes the value of A. This is byte number 1. So what is B? B is also will be byte 1, right? Now I do this, B plus plus. I do B plus plus. What is the type of B? 2. Yes. It would now move to here at byte number 2. And if I do dereference this, how many bytes is this b plus plus dereference gonna take from my data? Is a character, so it would take 1 byte starting at byte number 2. It actually would take only 1 byte because b is a character pointer. It's not an integer pointer. Right, y3. Now I'm confused. So b originally is 1, b plus plus, because b is a character. A character is 1 byte. So when you do b plus plus, this go to byte 2. All right. Let me know whenever you're not confused anymore. I'm sorry, I'm gonna keep explaining this. B start at 1 because I say b equals a. All right, with me so far, b equals a. A is 1, so b definitely at that point b is 1. All right. And let's break down star in parentheses b plus plus. B plus plus means I increment b. I increment b by 1 item. How big is 1 item for b? B is a character, by the way. B is a character, not an integer. Yes. Yes. Because b, I define b to be a character pointer. So 1 item for b is 1 byte. So when I do b plus plus, it's go 1 byte only, right? So now b points to byte number 2. Exactly. So when you do star b plus plus, right, it go to byte 2, look at that byte only and see what's in there. So what should be in there? My value is all the 4 bytes are 0. So yes, so in that case, you are still going to get 0. All right, with me so far. So what if I do this? After I do all this thing, right? After I do all this thing, I basically say now a equals b in the next line. What would happen to a? A equals b means what? What's the address of a that a is pointing? Yes. So now a points here. All right, with me so far. Now a point to this byte. So if I try to do this, star a, what would happen? It actually won't give you an error because there's nothing wrong with it, right? It's still going to be 0. Yes. What would happen is it would take this byte, so this byte, this byte, this byte, and this byte, and try to basically convert that number to an integer. All right. And that's it. It's kind of weird, yes. Most of the time you don't do that. Once you try to do this, it's likely there'll be bugs somewhere. So try not to do this, folks. It's just a way for me to kind of tell you this is actually can happen, and this because it's just because how you organize the data, right? And yes, I try make sure you try not to do this because it's gonna break somewhere. And if you try to do this weird trick, right? Unless you have a really, really good reason for that, on a code that say control a self-driving car or control an airplane, that sounds pretty dangerous, right? Also, so be aware of what you try to write. Um, but yeah, this is what is going to happen. And also it depends on where you store. Like let's say I want to store number 2, right? Do I put the number 2 in the highest bits or the lowest bit? So we'll talk about that later. We're not going to talk about it now, but be aware that this thing can happen. What of the, yeah, so there's a private chat asking, then what would the value of star A be, right? Basically, you take all the bits here. These are basically going to become some binary value, right? You take all those 4 bytes, and that's the number. In all likelihood, that's gonna be a 0 because I mean, what's the binary for 2? It's a bunch of 0, right? Followed by, at the end, 1 0. So it means that these are all 0, right? And then 1 0 at the end. If you take these bytes, let's change the color. I think I just destroyed that slide. So if I take this byte, what are you gonna see in there? A bunch of 0. Except, right? Except certain way you organize the bits. Even with that, I'm pretty sure it's gonna be 0. But I put an exception there because it depends on how you organize the bits inside each byte. Once you design a computer, you can do whatever you want with it because you become the law, right? You become you define the rule. In this case, in C, that's gonna be 0. Okay, with me so far? All right. Can I move on to the next slide and talk about now pointer? So a pointer can take a value, right? I can also make sure the pointer doesn't point to anything. Why should someone want to do that? Can someone tell me what would be the scenario that I want to make sure the pointer doesn't point to anything? When you just declare it, right? Because you can't you doesn't have the initial value for your pointer. What's the safest thing you can do? Don't throw a random address to the pointer. Give them a null value. It doesn't point to anything yet. Like that's kind of like the should be the default value for your pointer, right? In C, you can assign the letter null, right? Null would make sure the pointer doesn't point to anything. Accessing the value of this pointer is going to generate the error. But the beauty of this is one thing you can do. You can do something like this. If, let's say I have the pointer called PTR, right? In star PTR. That's my name, the name for the pointer. If PTR equals null, I can then check, right? I can then check, hey, have I assigned the address to this pointer yet? If not, do something. Otherwise, do something else, right? Any questions so far? Any questions so far? Yeah. So basically, it's kind of like, hey, stay there. It just like make sure it doesn't do anything yet. What if we did not add star? I mean, the star to this. Remind me when you do a demo. Actually, I'm not sure. We can try that. Yeah. Because it's not a pointer anymore. So I want to make sure that I am correct on this modern C compiler, like this version we use on Syskill, because it, like for example, sometimes the value for now is basically becomes 0, right? So if that's the case, it will compare if the value is 0 or not, but it depends on the version of your GCC. So that's why I said let's wait until we do the demo because I'm not sure. All right. It might just also say, hey, this is illegal. You're trying to compare a pointer with a value. Like something like that. Like depending on the implementation of GCC, by the way. GCC is also a program that someone writes to make sure it compile your C code into a binary. Yeah, that's a big area called compiler that look into how to optimize your code. Data type also has the size, right? Each data type has its own size. You can use the keyword size of to check the size of the data type, right? Size of int, size of float. Let's say you define a new data type A, you can do size of A, right? You can also star is called dereferencing. You dereference the address to get the value. Ampersand is called referencing. You create a reference or the address for the data. So what does this do? If I do star ampersand A. Yeah, it's basically A, right? I have A. I first reference that and then I dereference it. It's A, right? Same thing. Ampersand star A. First you dereference and then you reference it again. Why would you do that? Well, just so that I can ask you here. Most of the time you're not doing that. But you can do something like this. Right? In this case, it's kind of like I want to get the address of the value at A plus 2. I mean, this can be done. It's just like something can be done. Now, because we need to actually code something for real in assignment 2 and 3, right? Things to be careful. Please be mindful about these things when you're writing codes. When you use pointer, make sure you first declare that, obviously. Make sure the pointer is pointing to a valid location, otherwise assign them to be null. Just basically remember where the pointer should point to. Why? Otherwise, if you try to use a pointer that point you to some random location, it's gonna be illegal access, which will give you segfault. Which would crash your program. All right. Think of it as you're trespassing on someone else's data. All right, cool. Are we good? Are we good here? Clear, right? So these are the most common bugs that you're gonna see for assignment 3. This is it. Make sure this is apply. And I'm sure you could spend a lot of time trying to make sure this is true. Yes. So the question is, can I have two pointer 1 and pointer 2 point to the same address? And the answer is yes. This is possible. So let's say I have something like that. Actually, you're bringing an interesting question. Let's say I have pointer 1 equal pointer 2. And then I say star pointer 2 equals 10. And then I do printf. I print the content of pointer 1. What should I see? And let's say originally I have star pointer 1 equals 30. What is the number that I should see here? 10 is 10. Why? Because pointer 1 and pointer 2 points to the same location. And I say pointer 2, the value now should be 10. If I want to print the content of that pointer, even when I use pointer 1, it's the same address, so I should see the number 10. All right. Any questions about this example? Okay. Otherwise, let's move on to the next thing. We have to talk about this so that we can do the assignments, actually. We have to be able to handle input and output file. So there's a special type of pointer called file pointer. File pointer basically is a pointer that points to the beginning of the file and onward, right? The data type of the file pointer is literally called file. So in this case, you put in file star file pointer name. For example, you can do this file, right? Star fp. Let's say you do this. Then in the next line, you can do fp, which is our name for the file pointer. Fp equals f open path to the file, like slash home slash your username slash blah blah blah, or the dot slash path also works here. Mode can be R for read, W for write, right? When you open the file, then you can do whatever with the file. When you're done, make sure you close it. See how to use it here. There's a link here. Slide is posted on Canvas. If you can't open the file, it's gonna return null. Right. So one thing that is pretty safe and you should do is if fp equal fopen, why is it a good idea to do this? Not fp equals fopen. Basically, make sure it's not null. Why is it a good idea to do this? Anyone do a try catch before in Python? Yes, it is basically to avoid error. You don't want this to just crash your program, right? If you mess up the path, there should be some way to fix it without crashing the program, because otherwise the program might crash, right? So to read from the file, instead of scanf, scanf, right? And you add in the file pointer, such as fp, which is the example from earlier. This would read one integer into the variable called a from the file that you opened. This works with getC, getS as well, right? getC is get character from your screen. getS is get a string from your keyboard through the monitor. If you use fgetC and fgetS, it works the same way as getC and getS. Just put in the file pointer. So that's reading from a file. To write to a file is a printf. You can guess it. Fprintf. Okay, that's it. Write whatever you want to a file. Any questions so far? Any questions so far? If not, the next thing you need to be able to do is to check if this is the end of file. So the end of file is going to be denoted with a special symbol called end of file. You can then use a function called feof and put in the file pointer such as feof fp. It basically would check if we are at the end of the file or not. If this return true, what does it mean? If this return true, what does it mean? Yeah, we are at the end of the file, right? We reach the end of the file. If not, we can keep reading. That's it, right? That's the point of FEOF, to check that we read everything in the file. In general, file is a type of stream, and we have the stream IO, which basically kind of cover things like your keyboard input, printer, terminal, even things like network packets, right? Sample of stream, you can use file, you can use printf. Printf will print to your monitor. Fprintf print to the file. Sprintf is printing to the stream where you would have need to point to the location of the stream you want to print to. We are not going to use things like sprintf in this class, but it's useful when you have to develop some system level programming. We'll use fprintf, the normal printf, and we will use the file, right? Just something I want you to make sure you are aware of. And now this is the break in the middle. We'll do a quick break, maybe 8 minutes break. And I'm thinking about whether we should cover memory allocation now or not. Let's do it later. We'll cover the sample code after the break, and then we'll resume memory allocation in the next lecture. All right? So this will be done next lecture. We will first do we basically would play with pointer. There'll be 2 demos that I'm gonna talk about. And before we go to the demo, let's do a 7 minutes break. We'll resume at 3:10. So let me pause the recorder so that I can set up my desktop so I can do the demo. All right, so the first thing we want to do is a swap, right? We will begin by include standard.io.h just so that I can take inputs and print to the monitor. And I don't know what's up with my typing here. So many errors and typo. I want to return 0 to make sure the program executed correctly. Int I and j. I want to declare two variable. And one thing I want to do is do a scanf, right? And then I want to read two number into I, note the ampersand and j. So can someone tell me what am I doing here? I scan for two inputs, which are number, right? And then I want to print the two output back. But I want to write a magic function that I put in I and j, and after I run this, I swap the value. What does swapping mean? What does it mean to swap a value? Can someone tell me what would happen if I is 5, j is 10? After swapping, what should I see? What should be the value of I and j? It should switch the value, right? I is gonna equal j, j is gonna equal I. So without this function, so let me comment out this function first. How can I do this quickly inside the main function? So I can do this, right? I say temp equals I. Not I equals temp, because if you do I equals temp, I becomes some random uninitialized value. And then temp equal I equals j, and then j equals temp, right? This would allow me to swap the value, and we can confirm this first. Let's just confirm, right? By do gc swap c and then run it, right? Give me two number, please. 6. Oh my god, better number. I should have asked that. Okay, 1 and 8. After swap, you get 8 and 1. All right. I will not use those two numbers. I guess it's probably not YouTube appropriate, or like. Come on. Yeah, I think I should have known, right? I should have known what would be the number that you're gonna give me. So let me declare a function called swap and take I and j. Let's say I take I and j as an input, right? All right, let me do this. And then because I'm lazy, I'm gonna copy this and paste it here, right? Because I say input is A and B, I'm going to change this to A and B. And then I will just do this. Is this correct? Can someone tell me what would happen? After I run this, what would happen? Yeah. So first thing first, I don't return. So the function would get called and nothing happened in the main function, right? I put in I and j. I and j get passed down to A and B, and then I do the swap inside that function, but I didn't do anything to I and j, right? So yes, okay, good start. First of all, temp is not declared, so this will not even compile, right? The other thing that got mentioned in the chat, right? The swap only changed whatever happened locally in this function, right? It only happened locally in this function, which means that inside the function A and B got swapped. But outside of this function, ing is like nothing is done onto ing, right? So if I save and compile and run, I will get the same number, right? Oh, sorry, I want to win. So how do I fix this? How do I fix this? So can I use pointer? So instead of putting in A and B as an input, I take in pointers, the location of A and B. Would this fix the issue? Just look at swap function. Don't think about how I call it. Just you don't have to worry about how I call it. But if I pass in the address of I and J, is this a better swap? So what's the problem here? Great question. This is actually awesome. So I can say temp equal star A if if A is an address, right? Because what would happen if A is an address? So let's assume A is an address. Why is this okay then? Because star A, right? Then star A is a value, right? So now temp you store whatever is in the value point by A, right? And then star A equals star B. The old location of A will now takes in the value of where B is pointing, and then I do this. B, wherever B is pointing to would have the value temp. So if I change, sorry, if I change how I call by giving the address of I and J, can I swap now? So is this possible? It should be, right? Theoretically, this should work, and in reality, this works. So let's compile, right? And then run it and put in here. You swap now, right? If I put in now, you swap, right? I will make sure I don't use the number you give me. All right. Can you yes, sure, yes. So that's actually is a good decision. That's why I allocate a little bit more time here. So let me do it this way, right? I'll put in a comment so that I can organize my explanation. Okay. So on this line, right? On this line, what is star A? What is A? This is an address, right? This is an address. What is the value of A? Is the address of I, right? Are you all with me? Now A store the address of I because that's how I call the function, right? Swap, I give the address of I. Is it clear for at least for this part? Then B, what is B? Address of J, right? So if I want star A, what is star A? This is star, right? Address of I. So what is that? What is star address of I? Yeah, it's just I, right? Same thing here is star address of J, right? So it's just the value of J. So I do temp equals star A. Now temp is gonna have the value I, right? So now let's go to the next line. Temp Do we do anything with temp? No, right? So it stays the same. A stays the same. I am not modifying A. I'm not modifying the address. All right. I'm not modifying the address. So this is still the address of I. B also is still the address of J. What is the value at star B? This is J, right? So what is this? If I run this line, whatever I do here basically means that the location that A is pointing, should now have what? What should be the value of the location B is pointing? J, right? So now temp is I, A again is the address of I, B is the address of J, right? In this case, right, star A is J, star B should equal temp, this should be I. And I'll add two more things to make sure this is super clear. The value of I and J. The value of I and J in the main function. So I just do this. Is it clear? Basically, the value is I and J. So over here, the first line, the value of I is I, the value of J is J, right? On this line, the value of I is what? What is the value of I? It's now J, right? Why? Because I is the address of star A, right? So this should be J. I have not modified anything here, so that's J as well. So in here, J, and we modify the value of J to I. So now you see that we successfully swapped the two numbers together. Is it clear now? Any questions about this? So let me value table. So I'm gonna put this code out on the demo code on the server, so you can take a look at that later. Is it clear? Any questions? Oh, here. So basically, you said, what if I change this from J to I, right? You mean this? So it would first print. So this would be J. This would be I. The first %D is the first input. The second %D is the second input. So in this case, it will print first J and I. So in this case, it will print the same number because we do the swap, but we print the swap version of that. So we swap. Oh, okay, awesome. So let me change this back to make it correct again. Sorry. Why does it have to be star A and star B in swap in star A and star B? Okay, great. That's a great question. So your question is, why do I have to do this, right? Can't we do this? So your question is this, can I do this? Can I do this? All right. So in this case, my input is a value. My input is a value. And the value here is I and J, right? So this is basically what you're asking. Can I do this? This is actually a great question. And it's actually one of the things that can become a bug on your code if you don't understand this. So the problem here is if you do this, A and B becomes another variable. A and B is like a totally separate variable. It has the same value as I. B has the same value as J, but the address of A is not the same as the address of I. So you do the swap, right? So you would do the swap, but when you're outside of the function, A and B is gone. So is it clear now? So when you finish the function call, right? A and B is gone. And it go back to I and J, but because A has a different address than I, B has a different address than J, it's like you're not doing anything because you are not actually changing the value at the address of I and J. So that's why we have to put in the address of I and J. So there's a question way earlier, like way earlier in the beginning. Why can't I just do the swap and somehow I return something? So why can't I do this? Why can't I do the swap using return without using pointer? Yes. It's actually not because I said it's void, right? But if I want to return this, how many values am I returning? 2. Can I do that in C? Can I do that in C? Can I return 2 values in C? You can return an array, I guess. I guess you can return a pointer. You can return a struct, right? But it's annoying, to be honest, because you have to think like, okay, what do I do to return more than one? A common trick is instead of returning to value, it's like we don't do that here kind of thing. But one thing you can do is pass in the address so that you modify the content. After function finish, your content is there. All right, so that's also a plausible strategy. But what you said, you can return a tuple, you can return a struct, right? So you can say doing something like this. Pair of number, right? So let's actually do this. And then I would declare here, right? And then I do oh, it's gonna make a mess. Sorry, I'm gonna create a new function. You get it, you get my idea, right? What I'm trying to do. And here, instead of swapping ing, I guess I can call this. And then I have the oh my God. All right, what am I missing? What else am I missing? Okay, I need to do this. And instead of doing this test and temp, I guess one thing I can do is doing this. Return value dot a equals b. Return value dot b equals a, and then I return this. This could work too, but it's like, do you see how much effort do we have to do just to set it up and do the swap? See, So this is possible, right? But it's actually a lot more typing than you would have likely wanted. All right. So is it more clear that because it's programming, there's many ways to reach the solution that you want, right? And again, I want to show the way to use a pointer, but yes, you can do it this way too. You want to return a struct that works, you can do that. Any other questions? Great question. Can I add a method to a struct? The thing is, C is not object oriented, so you cannot really have a method inside a struct. But next lecture on Thursday, we will learn about something called function pointer that point to a function, and you can use that almost like a method. So function pointer is also a pointer, but it point to your code. It doesn't point to a data. It point to your code where the function call happened, and you can use the function pointer to call the function you want. So that kind of acts like a method, right? So hopefully does it answer your question? We are not gonna go into that exercise right now because we have a separate demo for that on Thursday. Can any other questions? Because otherwise, one thing the other thing I want to show, right, is how to use a pointer and array interchangeably. So let me do something like this. Sorry. Let's say I want to do a summation of everything in my array. Oh, where will you post the starter code in class 5? If I found that, I'll post it in class 5. If not, you can make your own starter code. Basically, use a random input of your choice. All right. This lecture will be possible to post on which day because the thing needs this later for A2. I'll try my best to do it by 6 p.m. How about this? I promise you, I'll put this on my calendar. Uh, Post MUIC lecture video, and that should show up at 5:45 today so that I don't forget. All right, I put that on my calendar, and I'll try my best to make sure I don't miss it. All right. By 7, YouTube should be done processing that. And then one thing I can do is sum equals sum plus ARI, right? So what does this code do? Can someone tell me what does this code do? It sum everything up, right? And print it out. What if I want to use pointer? What if I want to use pointer? If I want to use pointer, I can do this. All right. I will show this quickly that it actually works. Okay. So 1 plus 2 plus 3 plus 4 plus 5 is 15. Right? And yes, if you have to go to another class in a different building, go and run. Hopefully it's not raining right now, but if you have to, so I'm sorry, I forgot that you have you're at on campus. So if you have to run, go right now. It's just we had actually done. So let me copy this sample code to the directory that we have. Here. Oh, cp-r, my own error. All right. So that's it for the class today. I'm sorry we used a little bit too much time, but I thought we don't have a Q&A for assignment 2. And actually, I'm now glad. I'm glad that we don't have the in-class exercise because there's not going to be any time to do that. We'll see each other on Thursday. We'll cover things like memory allocation and function pointer, and we'll kind of do some practice with pointer and make sure everyone is comfortable with that, because this is, again, as I said, this is where the yes, sorry, I hope I do find my study code as well. This is where the fun really begin. All right. And this is basically where most of the material you need from this point onward for future classes. If you are comfortable using pointer, life is going to be much easier. Okay. That's it for the class today. Actually, I'll post the recording as soon as possible. So let me first stop this for the recording.